Today in class, we focused on exterior angles of a triangle. So last class, we were working with triangles, but we were looking at the interior angles. Today, we're going to be thinking about how the exterior angles are related. So first, let's define what an exterior angle is. An exterior angle is created when you extend a side of the triangle. So in purple, there's my original triangle. If I were to take one side of that triangle and extend it, that creates an exterior angle. So if I look at that extended side and the side of the triangle, that creates exterior angle labeled 4. 6 is not an exterior angle because if we look at the sides of angle 6, neither of those is a side of the triangle, so it is not an exterior angle. So we started the class exploring how to find the value of x in example 1. We started by finding the value of the missing interior angle that has the green dot in it. And using our knowledge from last class, we know that if we add 64 and 45, we get 109 degrees. And then to find the interior angle, since we know that all three interior angles add up to be 180, we can subtract 109 from 180, and that gives us 71, so that interior angle is 71. Someone in class noticed that x and 71, some people thought about it as a straight angle, some people saw that straight line here, so either way, the sum of those two angles has to be 180. So to find x, we would do 180 minus 71, and that would give us 109 degrees. So the value of x is 109 degrees. And as we did a few examples, some people noticed that the value for x was the same as what we got when we added those interior angles 64 and 45 degrees. That pattern held true through our examples, which led us to the exterior angle theorem. So someone in class said that the exterior angle is equal to not the angle right next to it, but the other two angles added together. So if we were going to write that using math vocabulary, that exterior angle is equal to the sum, meaning we're adding together, not the angle next to it. So I'm going to mark that angle out, and I would recommend you marking your triangles on your paper as well when you're working problems out. So not the angle next to it, the other two angles added together. Okay, so we already have sum for added together. And then those two angles, angle 1 and 3 in this case, we would call those the non-adjacent angles. So in this case, the measure of angle 4 would be equal to the measure of angle 1 plus the measure of angle 3. That is the exterior angle theorem. And we could prove that using our picture. So if we look at angles 2 and 4, because they would create a straight line or a straight angle, we know that they have a sum of 180 degrees. So the measure of angle 2 plus the measure of angle 4 is 180. We also know that the interior angles of a triangle add up to be 180. So on the right side of our scale, we also have 180, and that would come from the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. And since both sides of the scale are 180, those two expressions would be equal. So the measure of angle 2 plus the measure of angle 4 would have to be equal to the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. And we noticed that we had the measure of angle 2 on both sides of the equation, so we could subtract that to get rid of it. And when we did that, we got the measure of angle 4 equals the measure of angle 1 plus the measure of angle 3, which confirms what we noticed in our pattern. So to work today's problems, we are going to use that exterior angle theorem. So to work number 1, we're going to follow that same pattern. The exterior angle, in this case, the exterior angle is 115 degrees, is equal to not the angle next to it. So again, I recommend you marking that out, but the other two angles added together. So circle them, put a plus sign there. That helps us write our equation. That expression would be x plus 54. So our equation, 115 equals x plus 54. We are solving for x, so we can subtract 54 from both sides, and we get 61 degrees for x. So for number 2, if we follow that same pattern, our exterior angle, which is x, is equal to not the angle right next to it, but the other two angles added together. So that would be 66 plus 50. And in this case, we just need to simplify the right side of that equation. 66 plus 50 is 116 degrees. So then we can look at problems like number 3, and though it looks more complicated, we use that same thought process. The exterior angle, in this case, the exterior angle is 153. It is equal to, not that angle next to it, so we're going to mark that out, the other two angles added together. So that would be x minus 4 plus 2x plus 10. We can simplify on the right side of that equation. So x plus 2x, we have some like terms. That gives me 3x. And then we have a minus 4 and a plus 10. That gives me plus 6. And then we continue solving our equation. So if we subtract 6 from both sides, we get 147 equals 3x. If we divide both sides by 3, we get x equals 49. So we have the value of x, but that's not all, because the problem says to find x and to find the measure of angle ABC. So to find the measure of angle ABC, first we need to locate it. So if we start at A, go to B, and go to C, notice that that highlights an angle where B is the vertex. B is that corner point. And so what we're really trying to find is that the value of the angle at B, which is 2x plus 10. So then for the second half of my problem, the measure of angle ABC, we need to find the value of 2x plus 10. We know x is 49, so that would be 2 times 49 plus 10, so 98 plus 10. So the measure of angle ABC is 108 degrees.